DEFUSE is a language-agnostic framework that helps researchers collect failure-prone components from software repositories, check and eventually correct misclassified data, and build and evaluate machine learning models based on those data. It envisions four primary usage scenarios, namely collect infrastructure as code-based repositories on GitHub, compute repository metrics based on best engineering practices, automated mining of failure-prone and neutral infrastructure as code scripts and semi-automatic commit annotation, and finally, automated model building. The first step in using the tool is to connect a GitHub repository through a modal asking for the link to the remote repository and a personal access token. Please note that that token is required only when adding private repositories. Besides, public repositories can be collected from GitHub based on user-defined selection criteria, such as the creation date, the last commit date, the minimum number of starts, releases, and its primary language. To use the functionality though, the personal access token is required for DEFUSE to use GitHub's APIs. The token itself is provided by GitHub. Optionally, the user might want to select repositories based on metrics that describe well-engineered software projects and include the number of core contributors, the commit frequency, the repository size, and percentage of comments and infrastructure files. Afterward, when clicking on a repository, the user is redirected to the dashboard, where it is possible to mine the fixing commits and fixed files of the selected repository for a given language. This process is hidden to the user, who can still look at the current status in the task manager. The results are shown in two tables. A defect fixing commit consists of its hash, message, and the defects it fixes, for example, a wrong condition or an issue related to configuration data. A fixed file instead is a file modified by a defect fixing commit that is assumed to fix the defect. Currently, DEFUSE assumes that all the files modified in a fixing commit fix the defect only. Hence, it lets the user discard files categorized as fixing defects mistakenly, that is, false positive. False positives can be filtered out manually by clicking on the green dots in the table, which transit to red to provide a visual feedback. The related instances will be ignored during model training. Finally, a model can be trained for a specific defect and language in the model manager. At this point, DEFUSE labels all the snapshot of a fixed file in the release between its bug-introducing commit and fixing commit as failure-prone. The remaining files in the release are labeled as neutral. Then, code metrics are calculated for every snapshot to create a dataset for training the defect prediction model. The resulting model can then be downloaded for custom usage, checked for performance, or alternatively, it can be used for continuous integration using the provided GitHub action. For example, with the GitHub action, user interaction with the model is minimal. To use it, the user can simply copy the workflow example from the README file in the action repository and paste it in their workflow. Then, they only have to specify three parameters to run the GitHub workflow, namely, the URL to the deployed application, the language of the files to scan, currently Ansible or Tosca, and the ID of the model to use for the detection, which can be found in the Model Manager page. Once the workflow is pushed, it will be automatically run at every commit or pull request if specified, to facilitate code reviews by automatically looking for defects in the committed files and stop the workflow or notify the user if a given defect is detected. Finally, The prediction is shown in the workflow with its explanation. Thank you for watching DEFUSE.